Alright guys, so we are going to start off with doing Ohm's Law. Ohm's Law states that V equals C times R, which is voltage, current, and resistance. So if you look here on the board, I'll show you, let me move this. Okay, so our formula is up here on your paper, and it's voltage equals current times resistance. Sometimes current's represented with an I, and resistance. So down here, it tells you the unit in words. So voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. And sometimes in a practice problem you might see just a V, just an A, or this is a Greek symbol that represents ohms, and it means omega. Alright, so let's go ahead and start solving some equations. So let's look at the first one. It says there's a 28, remember this symbol, looks like a little horseshoe, it means resistance. So as we go, what I want you to do is start like boxing or circling the information that the problem gives you. So 28 ohms of resistance in the heating element is plugged into a 110 volt circuit. 110 volts. How much current passes through the heating element? So as you go, I want you to start to fill in over here. So does it give you a voltage? Yes, look over here. Gives you volts. So go ahead and plug in 110 here. Does it give you a current? Let's take a look. It does not, because it's asking you for how much current. It's asking you current. So I'm going to put an X or a question mark or something. And does it give you a resistance? Yes, 28 ohms of resistance. So just put a 28. If the triangle doesn't help you, you don't have to use it. V goes on top, I and R. Why is there an I? Well, because current's represented with an I. And then this is voltage and this is resistance. Okay, so let's plug in our numbers now. So let's put 110 into the V. And what goes in the R? 28. If you remember how to use the triangle, when 110 is on top of 28, we're going to divide. So 110 by 28. And we should, once you divide those two numbers, you should get 3.9. And what's our unit for current? Take a look back up here, down here. Amps, or you can just write an A. So 3.9, I'm just going to put an A. Okay? So we might have to flip back and forth to look at our unit. It's on the top of your page, but I'll probably flip back and forth. Let's look at the next one. Like I said before, circle the information that gives you. A lamp operates at 115 volts. 115 volts, so let's put it here. With a current of 0.45 amps, or A. Current 0.45. What is the lamp's resistance? What is the resistance? So we're going to put an X because we don't know that. Okay, so let's plug our stuff in. V goes here. I goes there. 115.45. When that's on top of that, what do? Divide. So 115 divided by 0.45, that's our equation. And once you do that, you should get 255.5, repeating. And what's our unit we just solved for resistance? So let's flip back. What's our unit for resistance? Drag it all the way down. You can draw the symbol. They're fun to draw. Good. So keep going. I'll do the next one with you, but I did want to show you one more thing. In class, we may have looked at this picture, but each little minion-looking thing represents our words in our formula. So if you look here, we have a volt. A volt means that it's pushing, it's the pressure behind a current. The higher the pressure, the stronger it's going to come out. So he's pushing this little guy trying to get through the wire or pipe or whatever he's going through. So think of it this way. If you had a water gun and it was shooting out, let's say we had a water gun and it was shooting out versus a fire hose. Look at the picture of a water gun versus, like, let's say a firefighter hose. A fire hose. Which one has more water coming out of it? Well, this one. That one has more water coming out of it. So that has a higher current. It has a higher flow. Current is represented in amps. Both of these have the same amount of pressure or voltage. Remember, pressure is volts. Pressure. I'm going to write this here. They have the same amount of pressure, this fire hose and the water gun, but the fire hose has much more current coming out of it. So that's the difference. They say that current's what kill you, not voltage. So let's go back to the equations. What is the resistance of a light? So it's even asking you up front the question, what is the resistance of the light? If the voltage is 12 volts, and the current is 0.3 amps. 0.3 amps. Well, which is amps? Let's go back to our formula. Amps, look for the word amps and follow it up. It's current. Okay, good. Now let's plug it in. Here. So 12's on top of 0.3. And you should get, when you divide the two, 40. In 40, what? What's our resistant unit? Follow it down and it should be the horseshoe. It's ohms. Alright, let's do one more, number 4. What is the total voltage in a circuit if the current passing through is 0.75 amps? So the current is 0.75 and the resistance is 35 ohms. So we just need to find volts. So I'm going to put an X on top. It's literally asking you what is the voltage. Okay, good. Now let's plug it in. 0.75 goes where the I is. 35 goes where the R is. So side by side. Side by side, we're going to multiply the two and you should get 26.25, and we're solving for volts, so what's our unit? Look back. The symbol in the unit is volt or V. Perfect. Okay, so finish up the rest of that sheet, practice, make sure you understand what each thing means. Remember, volts is pressure. It's not what kills you. Voltage is the pressure behind the wire. And amps, or current, is the flow. It's what is let out. So if we think of the fire hose versus the water gun, a fire hose has much more water coming out of it. So that's what will kill you, because you'll be exposed to more electrons at one time. And what's this guy doing up here? What is ohms? Resistor. What is he doing? He's resisting this little guy from getting through the pipe. So that's the resistor's job, is to control the amount of electrons being let out. So that's it. So finish up that sheet. Make sure you practice and look at your units. And we should be done. Thanks, guys.